Our number is 547B, as you see here, and this is 557 BC 557. This is the PNP transistor and this is the NPN transistor. Why we use the transistor? Because transistor base work on very small amount of current, like negative here and check here, so the negative will pass here because the diode can flow cathode to anode. Terminal positive terminal of multimeter on base, on the time it will be showing both reading, otherwise it not should be a reading. If there, I always use this calculation, so that's why I will share with you. To 12, so we got R1 26, so R1 is equal to 266.6. This voltage is power source means memory power bank. Combine the more transistors and make a one IC. So you can use operation amplifier, also have a min. Hello everyone, this is Ozil. Welcome back to my channel. So in this video I am going to explain you the transistor, how transistor work in the circuit, and how to identify the transistor and how to calculate the transistor base. If you want to interested to calculations and working, so do continue watching the video. Okay, so we have a two transistor here. So you can see there is a two transistor, as you see here. Okay, and now this transistor have a number is 547B, as you see here, 547B. Okay, and this is 557 BC 557. This is the PNP transistor and this is the NPN transistor. How transistor circuit, how its diagram, you can see this is the like a circle, and just connect here. Main depend on this diode connection. Okay, this is base, this is emitter, this is collector. Same here, this is base, emitter, collector. Collector always connect to load. Always connect to load, and emitter always connect to source. Okay, and this is the, you can see here internal diagram of this transistors. This is the NPN transistor, NPN, and this is PNP transistor. Okay, so if you supply the positive volt on this transistor base, on that time this negative out from collector. Okay, this is the main function. So why we use the transistor? Because transistor base work on very small amount of current, like 0.6 volt to 6 volt. Minimum voltage is 0.6 and maximum is 6.6 volt. If you supply this voltage on that time, it will be on. Okay, otherwise if you supply less than 0.6 volt, it will not work. And how it work, you can see here, this is the NPN transistors, and I make this like see as it is here. This is the diode. Okay, so in diode we can see here, in diode this is the anode and this is the cathode. Okay, anode can flow positive to cathode, but cathode cannot flow positive cathode to anode. It is not possible. Same here, when you put the multimeter negative here and check here, so the negative will pass here because the diode can flow cathode to anode negative, not positive. Okay, so when you check this here, when you put the negative terminal of multimeter on the emitter side of collectors and base of positive terminal of multimeter, on that time it will be a show reading. And whenever this base get positive voltage, on that time it will be on. And when you check the multimeter, positive here and negative you can put here, and also when you put here, both side reading will show. How? Because when you supply the base positive, on the time it will be a flow. So how? Let's see. Suppose, yes, we take a we have a multimeter. Okay, we have a multimeter, and multimeter I have set it in continuity, and we have a transistor here, same as it is here. This is the base, this is the emitter, and this is the collector. Okay, and now I am going to take a common red terminal common to the base. Okay, and we will check here and here like that. So we take common base red, means we have a red. Okay, so when we check the base to emitter, so we can base to emitter what we have. So when we check the base to emitter, we have a reading as you see here. So I will put here only right, R means reading. Okay, and same we will check base to collector, on the time it will showing reading also. So it is showing R means reading. Okay, now I'll take a common emitter red. Okay, so we take a common emitter red terminal of multimeter. Okay, now I will put here emitter to the emitter here common. I have taken a red terminal common emitter, and we will check on base. So we can say base to emitter to base, what happened? So emitter to base have no reading, so I will write ND means no reading. Same as it is here emitter to collector. So emitter to collector, what happened? So we can check and we will see there is also no reading. So we will see NR. Okay, now here also. Okay, I will put here. Now common, I will take a common collector red. So common collector red, when we take the red in common collector, on that time you can see here C to B, it has no reading, means collector to base there is no reading. So I can say NR. Okay, same as it is here collector to emitter, what happens? So when we check the collector to emitter, you can see there is no reading, so it will also a no reading. So when you check like this, so you should only the reading base, common base, when you take the terminal positive terminal of multimeter on base, on the time it will be showing both reading. Otherwise it not should be a reading. If there is here reading, on that time our transistor is faulty, we can get it, our transistor is faulty. But now our transistor is okay. Now we will check how to calculate the base of these transistors. Okay, so here we have another pages. Okay, so we have here, so we have a transistor, and if you see the transistor 547B, NP and transistors. Okay, when you see the data sheet, on the time you can see current max maximum current 10 milliampere, and voltage volt max 6 volt. Okay, minimum 0.6. if you supply the 0.6 volt on this transistor base, so it will be work, it will start switching. And if you didn't supply 0.6, you supply below the 0.6, on that time it will be not work. Got it? Now I will draw a diagram. Sorry, this is NPN transistors. Okay, this is NPN. Now we have a here LED. Okay, one side of LED have a 12 volt, and this LED work on 12 volt 35 milliampere. And when you check the transistor transistor data sheet, on the time this will be show on base to emitter. This is the base to emitter, and emitter to collector voltage, the current is max current is max 35 milliampere, and voltage max 45 volt. So we have this LED, and we have connected 12 voltage here, and negative side I have connected here, and this is the ground. So how we on the base? So we have to do the calculation, because we have a 12 voltage here, we have here 12 voltage, but we need minimum 0.6 volt and maximum 6 volt. So I will take we take 4 volt, but we have a current 10 milliamperes, and we have a volt also. So we will apply Ohm's law. It's also called a biasing, transistor biasing. Okay, so we calculate it. Ohm's law is equal to V is equal to IR. You can also apply the KVL law, but Ohm's law is very simple, and I always apply. It is my own experience. It is I always use this calculation, so that's why I will share with you. Okay, now so we need 4 voltage, but we have 12 voltage. So how many voltage we have to drop? So 12 minus 4 is equal to 12 minus 4 means 8. So we have to drop 8 voltage. We have to drop. So we have a 8 volt current. We have max current 10 milliampere. If you convert that in milliampere to ampere, it will 0.01 ampere, because you divide the 10 milliampere to 1000 if you want to convert it like that, 0.01. Okay, so we will put 0.01 into R. Okay, and now we will divide it. So 8 divided by 0.01 is equal to R. So here we can see we take a phone, and we will divide it. When we divide, it will take a clear 8 divided by 0.01, so 800. So R is equal to 800 ohm. So we got ohm, but I want to do the circuit like that. This is the transistors like that. When we turn on the 12 voltage, on that time it will be on. We cut out this voltage, on the time it will be suddenly shut down. That's why we called this circuit, we called a voltage divided circuit. So we have a total resistance, total R, we have RT, we have a 800 ohms, and we have to find this is R1 and R2. We have to find R1 and R2. We need how many voltage? 4 voltage, and we have a 12 voltage, and we have to find the resistance. So how will we find? We have to apply the voltage divider circuit formula. V out is equal to V in into R1 upon R1 plus R2. So we have a 4 volt output, and V 12 voltage V in we have, and we don't know R1, okay, but R1 plus R2 we have 8 ohms we have find here. So okay, 800 ohms we have to put here, and when we calculate it, so it will be 400 into 800 upon 12 is equal to R1. Okay, when we calculate it, so 4 into 800, sorry, 4, oh shit, 4 into 800, we got 3200. Now we will divide to 12. So we got R1 26. So R1 is equal to 266.6 ohm. Okay, so we have a R1 266.6 ohm, and we can easily find R2. So you just minus by 800, just minus 800. So we have R2 is equal to 533.3. okay, so the R2 value is 533.3 ohm. So this is called also transistor biasing. Because the current will flow here, and this will be a flow here. This will be negative to positive, and this is also negative to positive. It will be a flow like that. Okay, so that's why we calculate it, and we always use this circuit, this calculation, and we take you can see here, this is the project. We always made it like that, and we have lots of project we have made by own, and we always use this transistor. Now I will take one more example to explain in details. Okay, so we have suppose we have in Varna fluidic, always we can see here the ring light is always glow. When we turn off the ignition on the time, it will also glow. So the transistor how use in meter, just see and take a view. Okay, this is a series two LED connected to the series, and one side will connect it to the positive 12 voltage, and this will connected same as it is here, and one side of LED is connected to the transistors. And all one side is connected to the ground. It will be a resistance or direct. So and one transistor is connected here also, and it will be a positive, and this connected to the meter processor. If one transistor will get ground, it will be a short each other, it will be a short, or this will be a short from here to here. So this all ring light will be glow. When you turn off the ignition, on the ignition, that is nothing matter, because this voltage is power source. Power source means memory power back, memory power. When you turn off the ignition on the time, also this 12 voltage uh, exist in meters. Okay, and one more example. So if you have a rail pressure example, rail pressure sensor, there is three wires, one is ground, one is 5 volt reference, another is connected to the Ecm processor. Okay, and we have to pull up these transistors. We will check here, and it will be connected to the 5 voltage, and it is connected to one another signal. If another signal will not get from another IC, so it will be also not get this voltage. So the transistors, many use transistor in ECU, many places. Okay, so you have to know that how the load you can easily find via load. So suppose we have a load here, it is connected to the series, and one side is positive. So obviously this LED needs two negative and positive. If 12 voltage is present, it means we need the negative. Yeah, it needs negative, so it will connected to the collector of this transistor. So if we know that this load need this load have positive, but when this load will on that time, when this one side of LED get negative, then it will work. Okay, so when you see like this, so you have to know that it will be a conform NPN transistor. So when you trace out this emitter, it will be connected to ground via resistance or direct, and one side of transistor will connected to the another transistor, and it will also be a pull down. So this is the basics and fundamental of transistor. In the next video we will talk about on PNP transistor. This is the NPN transistors, and NPN transistor mostly used in ECUs and many more. If you get the transistor working on that time, you can easily find out this cruise board, because in many ICs the combination of more transistors and make one IC, combine the more transistors and make a one IC. So you can use operation amplifier also have a min transistor to make a one circuit, and also the Darlington also have a min transistor to use and make a one circuit. So this is the very simple and very easy. So you have to do the practice. If you didn't do the practice, you cannot get this. So guys, if you want to take courses on ECM repairing, so you can visit our website ramzon.in and join our courses online. Okay, and if you want to learn in English and Hindi, so both options are available. You can easily join our courses in Hindi and English. Both are easy, and I explain in very easy. And if you need don't need very complicated and calculation, you can easily just take a example and do the reverse engineering, and you can easily repair it. So if you didn't follow me on Insta, go and follow me on Instagrams. So thanks for watching.